You're listening to ARC Advisory Group's Digital Transformation Podcast, where we explore how people, processes, and technology converge in the industrial sector to shape a more digital and more sustainable future. In every episode, we talk with industry leaders who are navigating their digital transformation journey in practical and sometimes novel ways. Whether you're a business professional or just curious, these conversations will give you fresh ideas on accelerating your digital transformation through effective governance, change management, and application of technology at scale. From data historians to industrial data fabrics, industrial automation and robotics hardware, factory software to enterprise software, and the fast-evolving industrial AI ecosystem, there's always something new to learn. If you want to go further and make a real difference, be sure to connect with us at ARC Advisory Group. Our expertise can help your organization govern and adopt safe and secure industrial-grade technologies at scale, driving both innovation and results.
Welcome. I'm Colin Masson, the Research Director for Industrial AI at ARC Advisory Group, and I'm here today with Bryan Saunders, Global Director and Head of IoT Industry Consulting at SAS. Bryan, tell our audience a little bit about your role at SAS before we discuss SAS's approach to the AI and analytics lifecycle.
So I have the distinct pleasure of managing a diverse group of subject matter experts that reside globally, expertise in various fields, whether that be manufacturing, energy, transportation, oil and gas, healthcare, public sector. We cover a pretty wide range of opportunities for our business. Really, our primary goal, regardless of that field, it's to help customers understand kind of the planning, adoption, and execution of strategic roadmaps for analytic solutions. That's sort of our North Star that sort of dictates kind of our day-to-day engagement models.
Thanks, Bryan. Let's perhaps start with a question on managing data. In our annual survey of over 500 industrial organizations at the end of 2023, we found that AI came out as the most impactful technology, or at least what they think is going to be the most impactful over the next 3 years. And that was a repeat of 2022, although there was a 35% jump, right? In let's call it that hype of Gen AI has definitely had a positive impact on AI spending and investment. But we also found in a companion report that we did on leaders and laggards and what they were doing in the industrial AI investment area, we found that the biggest technical challenge for leaders and laggards alike was data quality. And as you and our ARC audience know, there's no shortage of data in the industrial sector, and certainly they're not new to AI. But what are your thoughts on how does SAS approach that data quality problem, and particularly related to AI?
Yeah, so at SAS we tend to talk about sort of many of these concepts through the lens of an AI and analytics lifecycle, which really comprised of three main areas: management of data being the first, development of models, and then deployment of insights. And I think we all kind of understand that the foundation of analytics is data. So that's been a core set of our capabilities that we offer to help, in terms of data access, data preparation, and data governance through the lens of these analytic decision-making processes. As I think about data management in the world of IoT and kind of across the industrial landscape, I tend to just use the little tagline, any data, anywhere, because that's the current realities as organizations are facing challenges with data that's not only at rest, sort of those traditional data systems, but also data in motion. That kind of, and the mix of data, you talk Gen AI, it traditionally in IoT and industrial, we're thinking measured sensors, temperatures, pressures, flows, using that around a device to derive some useful insight. But it's moving towards much more text and document, natural language based data challenges. And so it's certainly within the same lens that we attack these problems, but it's growing. And beyond that, compound it with video streams, acoustic data, the volume and the variety never changes, or never stops changing, I should say. I think regardless of the type of data, though, I think you rightfully pointed out, success is rooted in their ability to manage the quality of that data, because quality data leads to quality decisions and improved outcomes. And so as I think about one of the big challenges that organizations were struggling with, it's that data in motion. And it's creating new challenges, forcing new ways of thinking, not only in terms of kind of where data is generated, whether that be at the edge, in the cloud, or in between. But now the data management, when you think about these distributed execution environments, data management is now very tightly coupled to the analytic runtime and to the model that it's supporting. It's no longer sort of a standalone pillar. It's really distributed across many phases of that life cycle. So I think that's certainly a key focus. And then I mentioned the last phase, governance. I think folks have heard that term, and in the world of analytics or software development, people tend to think of governance as, oh, that's my source code repository, right? I'm governing, I'm managing. But the data has a lineage and a life cycle that organizations have to better understand, can have that traceability, especially in regulated or controlled environments, because what you do, where the data came from, and what operations you took on the data that led you to make a business decision that could have very benign impacts or very significant impacts to your employees, to the environment, just industry at large. It's certainly something that we're very focused on, and we've got a track record of sort of building that into our offerings.
Okay, so any data anywhere, and just to echo your comment on governance, we certainly found that again in that leader laggard report, that one of the characteristics of leaders were that they were more likely to have data and AI governance in some form of governance council, multidisciplinary. So certainly we see that as one of the characteristics of those leaders in adoption of AI in the industrial sector. But I did want to ask you another question about data, and I think it ties in with your any data anywhere, because I see a lot of customers investing in data lakes, enterprise data fabrics. I won't name names, but you kind of know who they are, right? And those initiatives are often led by IT, and somehow there's this perception that you have to move everything to the cloud to make progress with AI and analytics. And we've been advising clients that maybe that's not the case. There's a lot of value in edge data, particularly when we're talking about petabytes, right? In some cases of data being generated by today's digital factories, or they're just producing data at incredible rates. A lot of it's untapped, and I guess that's really where you come in, right? So with your track record as SAS and your ability to access, manage, and govern data from the industrial edge as well, with your IoT platform and background in that as well, what's your advice and approach when customers, do they have to move all their data? What's your advice to those industrial customers?
Yeah, so, let me start by saying I agree with the premise that there isn't really an industrial grade data fabric available today. And frankly, I'm a bit on the fence if I feel that's a good thing or a bad thing. And kind of what I mean by that is certainly there's value in having well thought out standards and frameworks in place across industry, enterprise and industry at large, because I think that does give the way for maybe an improved pace of adoption and interoperability across systems and infrastructure, which I think is one of the impediments of IoT today. However, kind of where I think it may be a bad thing is I've seen organizations on this pursuit of a utopian data fabric as one of their biggest impediments to success. They get so paralyzed by, I need all data across all systems, standardized, normalized, cataloged, inventoried within their cloud infrastructure. And the reality is that that's just not feasible. It comes at a Herculean cost and a lot of effort. And with that cost and effort comes time, and time is the enemy in industrial operations or any industry these days with analytic programs. People lose patience. They're not seeing those returns. So again, I think that is a real problem. So, those organizations that are investing into their programs, trying to drive that consistency across their operating facilities, I think they struggle, because I think you and I would agree that, we talk to a lot of manufacturers and they have lots of facilities. And usually the only consistent thing across those facilities is the name on the building. They use various vintages of technology. They're instrumented to differing degrees. Levels of automation adoption vary from plant to plant. They create a very diverse product mix. So those challenges, I think, are part of the reason why organizations that take that sort of big bang approach have struggled. And so my recommendation has always been, start small, focus on value. I identify an issue within one facility that's driving excessive cost, inefficiency, waste, and look at the data you need just for that use case. Like, don't go, if you're doing predictive maintenance and all you need is time series sensor data, I don't need to bring in all my ERP and MES data and all, billing and sales data. You're just opening a can of worms that doesn't yield a lot of benefits. So I think if they do so and they really start to constrain, we're going to find the data we need for this problem to drive this known quantity of value and get there quickly. That becomes a building block in the broader sort of data fabric. And so I think as they tackle these problems, they're able to quickly realize value, scale up their successes, and scale out as appropriate on a use case by use case basis. You'll hear this referred to as sort of a crawl, walk, run methodology. I think those quick wins, have proven that they can be a great catalyst for organizational momentum. They fuel these new innovation projects. You get people excited. They want to tackle more and more of these problems. And pretty soon you have enough building blocks in place that you start to see that industrial grade data fabric sort of taking shape right before your eyes, even, though that wasn't the initial goal. So certainly that's where I recommend. Edge has created a new paradigm there, as you mentioned, and it's sometimes that data does not need to be transferred to the cloud or stored or historized over long periods from a cost perspective and just a speed of decisioning perspective. Oftentimes, milliseconds matter in industrial enterprises. So if you have to move all your data and then learn from it in a cloud, you might be missing some opportunity. So that's kind of where that edge interplay is quite prevalent today.
Okay, thanks, Bryan, for that very pragmatic approach to managing data, tackling the problem one use case at a time, and assembling an industrial grade data fabric, because one doesn't exist today, right? I don't think it will ever exist, but I shouldn't say that too loud, right? Let's move on to developing models, the second phase of SAS's AI and analytics lifecycle. And I know I'm beginning to sound like a broken record when I remind ARC's industrial clients that we've been using data science, machine learning, neural nets, reinforcement learning, heuristics, all forms of AI for decades. And every industrial AI use case typically may need a different set of techniques, tools, and training approaches. In other words, pick the right tool for the job, and not to be dismissive of Gen AI, but it's just one more tool in our industrial AI tool set, and it's a pretty expensive tool as well. So how do you approach, when your industrial clients are really looking at which tool to use in that industrial AI tool set? What is your approach? How do you advise them?
Yeah, well, I'm shocked to hear that Gen AI isn't the silver bullet that's going to solve all of our problems moving forward. But no, in all seriousness, we certainly see the power of Gen AI, but we also realize that to your point is just one tool in the toolbox. And so as we start to think about this phase of the analytics lifecycle, where we're kind of moving into that model development loop, it's really trying to drive efficiency and value in the model build, validation, and optimization phases. And I think when most folks hear the term analytics, this is where they naturally align their brains. They go to, oh yeah, I'm going to go do some data analysis. I'm going to create or train a model based on my problem set. But I think that sort of traditional view is also one of the problems. Most folks believe that in order to engage or participate in this phase, you've got to be a developer. You got to be able to program, or a professionally trained data scientist. And I think that's a misnomer. That's a point of emphasis that SAS has invested heavily in technology and solutions to expand the resource pool. I'm a mechanical engineer, not a data scientist. So the goal is to provide access to subject matter experts and what I would maybe call a citizen data scientist. You're sort of a hybrid in between. You've got a little data science chops. You understand some of the basics. But in my view, as a subject matter expert, I shouldn't really care what I'm using. Is it a regression model, neural net, decision tree? It should really be focused on what is the business outcome I'm trying to achieve. And a lot of that complexity needs to be abstracted. And it usually comes down to cost. You mentioned that, you don't have infinite budgets to go. You don't want to train a large language model to do a threshold alert on a pump temperature. That would not be the best use of funds. So it's really coming back to helping customers expand and use a larger percentage of their workforce, freeing up their more skilled users to go after the complex, challenging of problems. I think they see quicker value. They're able to scale up, drive better return on investment. I think probably just the best way to summarize it, and maybe it took me a while to get here, but really there's a continuum of capabilities that really is driven by what data do you have. The data you have may dictate the analytic methods that can be applied. What is the expected outcome? Are you doing anomaly detection? Are you doing a forecast? Are you doing remaining useful life calculations? Obviously, that will also dictate what class of AI is best suited. What is your organizational maturity? If you are just getting started, you probably don't want to put a bunch of neural nets out into your production facilities for the realization that as an engineer, model interpretability often trumps model accuracy. So if I don't know what the model's telling me, I'm probably not going to do anything with it. So again, I think as complexity goes up, change management and adoption hurdles go up with it. And so I think organizations need to really balance data outcomes and maturity, and more importantly, cost, as you've rightfully highlighted.
Yeah, and it's funny, in another conversation with the chief AI officer, he kind of talked about 80% of their AI deployments, their solutions that they were delivering for customers, were not using Gen AI. We're using narrow AI techniques or algorithms and proven methods, partly because they are almost an order of magnitude cheaper to actually deploy, and they're more accurate. And in many cases, to your point, they're explainable, right? You can actually understand why certain recommendations or inferences are being made. So certainly, but I do love the SAS AI and analytics lifecycle concept. It's very much aligned with ARC's industrial AI use case lifecycle that I included in our vision for industrial grade data fabrics. And as we've already said, no one really has the full vision, right? I've been pretty transparent that, I don't believe there is a one-stop shop or platform that can address the wide range of data type stores and models for all of our use cases for AI end to end across the industrial value chain. But we are seeing people try and assemble them, right? And in a previous conversation, we talked about, your advice that people go after one business outcome, one use case, if you want to call it that, at a time. Can you share some examples of how you're helping realize that vision of one use case at a time, and helping customers, SaaS customers, kind of build out that industrial grade data fabric?
Yeah, so I will. I'm based in Atlanta, so I'm gonna have some bit of a homer here. I'm gonna pick some companies that I work with right in my backyard. But Georgia Pacific, they're one of our key customers, and I would consider them a partner. I think we're on this analytic journey together. For those that don't know Georgia Pacific, they're a world leader in pulp and paper industry. And like many manufacturing organizations back during the COVID era, they were facing challenges, and those challenges were pervasive. They were, how do they maintain critical equipment uptime to meet production demand? How do they maintain the highest levels of quality to reduce waste, protect revenue, keep products on shelves? That was a real problem. And, the most recent hurricanes that started to creep back into the hoarding of paper products. And more importantly, to protect the safety of the workforce. They understood that these challenges were not going to be solved using traditional methods. So they wanted to really lean in on analytics. They had certainly invested, but they were struggling with capitalizing on value. They had teams where they, I think, on that last mile of the analytic journey, really tying it back into their business operations. That was a main big hurdle for them. They approached it, I think, in the right way. They said, look, we know that this is, we can't eat an elephant at once, one bite at a time kind of mentality. And we said, where is your biggest pain point? Where is the biggest problem? And they're like, well, probably the most consistent problem we have is in our maintenance of our rotating assets, pumps, motors within their facilities. And we have lots of vibration data. We'd love to be able to process that, derive better predictions when these assets could go offline, better planning for our emerging maintenance requirements. So we said, okay, let's start there. Let's just look at vibration data. And again, that was the first building block, their time series data pulling from their OSI Pi investments. Now Aviva Pi, I should clarify that.
Yeah.
And then when we the next problem was, okay, now that we're improving our uptime, we would like to tackle some of the quality challenges, our throughput, the velocity of products that we can generate. How do we optimize set points? And that moved into their quality realm where you needed more of their MES data, et cetera. So you start layering in those other data systems to create a more complete canvas to derive more advanced models. Then the next phase was kind of that worker safety. This became paramount that, well, how do you instrument worker safety? So they were like, well, we have lots of cameras. We would like to monitor movements. Are folks getting within harm's way of running conveyors and paper machines that could lead to injury? And a lot of that was tied to workforce turnover. You had folks that weren't as knowledgeable. And so they started working through computer vision and other data systems. And so slowly, bite by bite, they were able to sort of build this landscape. And then after they had kind of run a project through all of those disciplines, the next project was just so much easier because they already had that foundation in place. And they do I think in terms of model development, they're a bit of an anomaly, in my opinion. You can tell they weren't like hardcore data scientists that created this group, because their mantra is good is good enough. Now, most data scientists never say good is good enough. Pursuit of perfection is really their North Star. But they said, look, we want to put something into production that makes us incrementally better today than we were yesterday. And we're going to learn, and we're going to improve, and we're going to update that model. And so the day after, we're better than we were today. And so they have that day by day mentality, that relentless pursuit of value. Kind of another example is from a adjacent transportation industry. We work with Lockheed Martin. So Lockheed Martin has C-130J aircraft, transport humanitarian aid type aircraft. And they supply these to government entities across the globe. And there's quite a bit of data challenge. So we started with them purely on better data integration, better data management, and cleansing, because they were paying a lot of folks to do that work. And then they're like, okay, now that we have our data done, now we'd like to start doing spare parts forecasting and optimization. When we send these aircraft out for missions, how do we better prepare our customer with the right set of spares? And then they move into intelligent diagnostics. So now once the mission's complete, can you learn from the data coming off the aircraft to more quickly identify emerging maintenance needs and prioritize a corrective action plan? And so again, each use case sort of built them kind of that next layer of the data fabric. And I think they have achieved significant successes within their enterprise.
Thanks for those great customer examples, Bryan. And I actually know Mike Carroll and the GP team pretty well. And in fact, I'm hosting a leadership summit with them because I think they're such a great example. So that one certainly resonated with me.
Mm-hmm.
So let's move on to perhaps talking about deploying the insights from all of these, whichever AI technique you actually end up using. We did in our Leader Laggard survey kind of in January, we surveyed 525 industrial organizations and their progress on 25 use cases. We won't say they are the magic 25 or anything like that. It was just kind of 5 representative use cases in supply chain or in production operations or in sound and service, etc. Right? Just to get a feeling for where they were prioritizing their AI investments. But what we did find was there was a growing digital divide between those who had already digitized their data, connected their sensors, machines, factories, and those who were frankly already behind on that digital transformation journey. Mm-hmm. And we did identify a few use cases which were more pervasively adopted on others. I'm interested to hear from you, Bryan, on what are the ones that you find you are doing over and over again or are getting the most traction. So which particular use cases or outcomes are you seeing?
Yeah, well, I think I've seen the commonality in many of the laggards is they're not thinking in all times about the use case. They're thinking about, well, I have to make these technology investments to build the data fabrics, to instrument, to automate, to collect, store, build my cloud infrastructure. And I think those that are leading have really taken that next step in the journey where they're really trying to align their outcomes that really move the needle for their business operations. And I think fundamentally, we've kind of, I think you hit on this and, I believe it. Analytics is about so much more than just the model. It's about the ability to operationalize and scale those insights. And those insights have to be tied back in to an existing business system, all the investments that you talked about. But most manufacturers that I go into, they don't want to adopt new systems. They want their analytic investments to tie into their existing systems so that they don't have to teach employees a new system. They're not having to learn new applications in order to do their day-to-day jobs. And I think that's a critical component of kind of this digital transformation journey. But, in terms of the use cases probably the use case that I see over and over, and maybe it's just because my background, predictive maintenance. Predictive maintenance is that continues to be the killer use case for IoT. It is so pervasive, whether you're talking manufacturers, energy and utility companies, public sector with big, large fleets of assets. I mean, there's just so much commonality that you see a lot of a rinse and repeat in the predictive maintenance realm. The other one, as I think more, if I kind of lean into manufacturing a bit, just given the kind of the industrial flair of the conversation, manufacturing quality, production quality and control is probably the next big issue. And that for good reason. They're both extremely valuable. They drive tremendous dollars and cents to the bottom line. I've talked about Georgia Pacific and their journey for analytics, and I encourage anyone out there to kind of go listen and learn from their experiences. They have a great story to tell, but kind of in that predictive maintenance realm, they adopted and scaled across their facilities, achieved 30% downtime reduction in their critical assets. And then compounding that improvement with their quality improvements, they got a 10% improvement in OEE, overall equipment effectiveness, which was, everyone that's kind of in that space, you can probably do the math in your head that, wow, that's significant value for an enterprise. 1 percentage point of OEE is valuable. 10% is pretty special. Beyond those are kind of been those core foundational use cases. We're seeing, I think even in our consumer world, cost of energy is going up, not coming down. And because of energy, I think this isn't a temporary blip. This is a real shift that we're going to be dealing with for years to come, especially in Europe. They're going through quite a bit of instability with Russia, Ukraine, natural gas supplies are constrained. And so organizations there are like, how do I reduce my energy spend? How do I optimize the amount of inputs that go into my manufacturing process without sacrificing the outputs that I want to achieve? And so energy cost optimization, we worked with a large brick manufacturer, Wienerberger, largest in the world actually, to address that problem of really looking at where they were using energy and how to reduce that without sacrificing the quality of their brick manufacturing. And they were able to get a 15% reduction in their natural gas bill every month. And that certainly adds up as you think how that cascades into the future. And they continue to look for new ways of driving those sustainability initiatives. I mentioned, probably another one of the parts of manufacturing are the people. So worker safety continues to be top of mind. I think according to the U.S. Bureau of Labor and Statistics, about a 9% year-over-year increase in work-related injuries over the last few years. And I think part of that is the workforce turnover. I think part of that is just being, there's more and more complexity showing up in industry. And so by using cameras and other technologies to better monitor and can understand workforce behavior, we're able to see a 50% reduction in sort of the near misses through just more proactive education and training, not being punitive, but just saying, most injuries don't happen the first time you do it wrong. You get hit on the 8th time out of 100 times you try it, you finally pay the penalty. And through that improved training, we're seeing reduction in reportable incidents by up to like 20%, which That's significant for an enterprise. And then kind of stepping outside of manufacturing, heavy utilities focus, and that covers a pretty wide gambit of predictive maintenance on their generating assets, vegetation management and on their transmission and distribution lines, looking at growth rates of trees and species identifications and health and all of those things that vision-based and LiDAR-based imaging models can add value to. Another one's load forecasting. I mean, the energy mix is shifting dramatically. So by being able to give organizations, utilities, the ability to forecast the net load demands over various time horizons, we can help them and many of their short-term goals, such as dispatch and day-to-day operations, but also long-term planning. When am I going to reach a pinch point where I may need to build excess capacity? Those are not short-term goals that you can just say, oh, I'm going to add a new gas turbine or a new nuclear facility in the next year. There's a lot of time horizons there. So helping them kind of manage that uncertainty is a big push for us. And it's only been compounded by this thermal, renewable, distributed energy systems. Right. And then beyond, traffic optimization in public cities, I think that's becoming bigger and bigger problems.
And we could go on and on, right?
Yes.
No shortage of use cases that we can really go after. And I think that's why everyone's so excited, right? But interesting enough, and I can confirm that we also found in our leader-lagged report that kind of predictive maintenance and quality, and you kind of highlighted a lot of the quality and safety, even some of the supply chain use cases, many of them are more about computer vision or machine vision techniques than they are about large language models, right? And of course, predictive maintenance is good old machine learning, right? And so, but by the same token, we do see a tremendous role for Gen AI in becoming that new UI for interacting with almost any complex system. And of course, we have lots of complex systems in the industrial sector. And we're seeing it being simplifying access to industrial software as co-pilots, assistants. Talk to a supply chain vendor who happens to be calling them genies, right? And I haven't seen Clippy 2.0. No, I tell a lie. I did see Salesforce CEO reference Microsoft's Copilot says Clippy 2.0. And so that was obviously a bit disparaging. But anyway, we're seeing lots of that kind of assistance in interacting with knowledge bases and guiding people through the next step in complex systems. So really as a way of accelerating ramp up, deployment, tuning and maintenance of their complex software. What's SAS doing with Gen AI?
Yeah, so, I think as you described, there is no shortage of innovation in this space and Gen AI. I don't think anyone can really argue with the transformative force it is today, but where it can be in the future. One of the challenges, when we talk generative AI, the whole intent, it's generating new content based on an underpinning of training data and model and data and documents that we provide. Well, historically, that generation can lead to false answers or hallucinations. And so at SAS, our bedrock is to create the most trustworthy analytics in the world without bias. So keeping those two sort of concepts on the table, it really has driven our investment strategy. And it really covers probably three key areas as it relates to analytics. The first is really synthetic data generation. It's really good at creating believable real world data. And many of the organizations that we run into, they may have just instrumented assets within a facility and they don't have a lot of history. So some of those analytic techniques that that thrive on large volumes of data, they're not available to you if you don't have the right data to feed the models. And the cost of acquiring new data can be quite expensive, quite high. So we're really seeing this as a great way of accelerating model development, model tuning, model accuracy, especially as it relates to some of these sparse events or fringe use cases that don't happen all the time. You can now sort of synthetically create data to test the full spectrum of your analytic models, becoming much more resilient to some of these rare conditions. We are creating models. There is code underneath the hood. So we do have co-pilots, again, trying to make that subject matter expert. Let me just ask a question. I want to build a predictive model to detect vibration anomalies on this class of asset in this facility. Well, as an engineer, I know what I want to do. I just may not know how. And so these co-pilots are a great equalizer to do the heavy lifting behind the scenes, where it's a more natural way of interacting for some folks. And so we see tremendous benefit there. And but I think for industry, the area is sort of these digital assistants. And I think, when I look at manufacturing, just as a microcosm, tremendous workforce turnover. I mentioned you'll go into facilities and you see individuals that have been in their role for 12 months, 18 months, and they're operating really complex processes or very expensive pieces of equipment that normally you would have seen a 5, 10, 20-year veteran operating. Well, the reality is a lot of those folks are departing the workforce. You with this new technology has created that turnover. And so I think these digital assistants are a great way to sort of upskill workforce and level the playing field so that you get consistency in your operations. You can learn from the folks with the experience and institutionalize that back into your process so that whether Bryan's doing or Colin's doing it or, a new hire off the street, we get very seamless and repeatable outcomes. So we're kind of looking at it across sort of the meat and potato of data and model creation, but also more from an industry solution perspective and how that can be best adopted.
Thanks, Bryan. I think that aligns pretty much with what we're seeing in terms of Gen AI's biggest impact, perhaps for us in the industrial sector, is in helping to address the skills gap, knowledge transfer. And that on its own is hugely valuable, right? And so it's been great talking with you, going through the AI and analytics lifecycle. So thanks very much for that.
Well, thanks for your time. Thanks for having me.
Thanks. You've been listening to Colin Masson of ARC and Bryan Saunders of SAS discussing the AI and analytics lifecycle. For more on today's topic, download my ARC view titled Industrial Grade AI, Transforming Data into Insights and Outcomes from arcweb.com, or follow Bryan Saunders and I on LinkedIn, where you'll find transcripts of today's conversation online and links to that white paper. So thanks very much for listening to us today.
Thanks for tuning in to ARC Advisory Group's Digital Transformation Podcast. Today, we explored how to accelerate your digital transformation through effective governance, change management, and application of technology at scale. Now's the time to take what you've heard and start implementing these changes in your own work. Please share this episode with others who are passionate about applying technology the right way to address skills gaps, create more intelligent processes, while building a more profitable and sustainable future. For those looking to go deeper, ARC Advisory Group offers unparalleled guidance in developing digital transformation strategies for industrial organizations. Please reach out to us for these expert insights and support that can help you turn these ideas into action and lead your organization towards a more profitable and sustainable path.